Okay, so hi everybody. Today we have a Codeforces round again, and this is an educational round. So let's see how it goes. And yeah, okay. So let's go. Okay, problem A. You have a board represented as a grid with 2 into n cells. The first k1 cells of the first k1 cells of the first row and the first k2 cells of the second row are colored in white. All of the cells are colored in black. You have W white dominoes, 2 into 1 tiles. Both cells are colored in white, and W and B black dominoes. You can place a white domino on the board if both the board cells are white and not occupied by any other domino. In the same way, you can place a black domino if both the cells are black and not occupied by any other domino. Can you place all W plus B dominoes on the board? If you can, okay. So in the first test case, n equals to 1 and k1 equals to 0, it means, so you can't do that. The first k1 cells of the first row and the first k2 cells of the second row are colored in white. Okay, so are colored in white. And what else do they give us? The second line contains W and B. K1, K2, and then we have white. N minus K1, N minus K2, and B. C minus equals to X, and then we can, yeah, then the remaining equals to int rem equals to Y minus X, and then we'll have to put a whole domino horizontally in that case, so C minus equals to rem by 2. So let's see if this works. I don't know why it is so slow here. Okay, there were test cases as well, right? So we have no yes, no yes, yes, yeah, that is fine. So I'll submit it. So great. We are through with the first problem. Moving on to problem B. And it says you're given a string s consisting only of characters 0 and 1. Let mod s be the length of the string. Okay, you are asked to choose some integer k and find a sequence a of length k such. You're asked to choose some integer k greater than 0 and find a sequence a of length k such that a1 is greater than equal to 1 and a2 is greater than that. So we have an increasing sequence, and ai minus 1 plus 1 is less than ai for all I from 2 to k. Yeah, this is fine. So if we have 1, then we can only have 3 there. ai is greater than ai minus 1 plus 1. Okay, the characters at position a1, a2, ak are removed. The remaining characters are concatenated without changing the order. So in other words, the position in the sequence a should not the positions in the sequence a should not be adjacent. If we have 1, then we can only have 3, right? Fine. Does there exist such a sequence such that the resulting string s dash is sorted? It is sorted. Fine. So we need to remove all the basically remove all the zeros till there is a 1 to the right side. Yeah. So yeah, we need to remove all the zeros from the left side till the point such that after that 0 there are so if there is a 0 such that there is a 1 to the right side of it, then we will have to remove it. Yeah. And if all of them are 0, then we are also done. So and if it is not okay, that is all the characters are not same, so there are both zeros and ones, so we need to remove all the zeros such that there is a 1 to the right side of that. Or in fact, we need to remove all the zeros here. We need to remove all the ones. We need to remove all the ones such that there is. Oh, okay. You can either remove a 0 or a 1. So if we have this, then we will have to remove either all the ones or all the zeros here. But let's say we have something like this. Then if I remove all the ones here, I can remove these and then it will become sorted. So we should not keep a 1 such that there is a 0 to the right side of it. Similarly, we should not keep a 0 such that there is a 1 to the left side of it. Yeah. So if I am here and I need to see if I need to remove it or not. Okay, can I do it like a DP? I think I can do it like a DP here. Okay. So if I have my DP like this, that I'm at index I, and if there is a 0 in the prefix that I have not removed, then I will mark this index 1, and yeah, this is like, I can keep it like JK. So this is 0 if I have a 0 in the prefix, and similarly this is 1 if I have a 0 in the prefix here. Similarly this is 1 if I have a 1 in the prefix here. So the values here can be 0, 1, and similarly here it can be 0, 1. Next I can keep a variable if I have removed the last element or not. Yeah, so this should be fine. This is like an n into 8 type of a DP. Yeah, this should be fine. We are at index 0 and we haven't encountered any 0, we haven't encountered any 1 till here, and we haven't removed any elements. Yeah, so this should be 0. Yeah, seems fine. So, and we also need to pass it the DP, so I can make it global here. So if dp at index comma mask is not equal to -1, then I return that. So if I set I -0, if mask and 8, that is, we have already removed the previous element, so we cannot remove this element. So if you are at 1, then you can only have zeros. Yeah, then you can also have 1. If I set index, if p equals to 1, then I take my answer as dp at index mask equals to helper. So we have encountered a 1 here, so we will do an OR with 4. And what should we do? We should do a XOR with 8 because we want to flip that bit. Yeah, and then I do n comma s. So if p equals to 1, yeah, so if p equals, else p is equal to 0. So if mask and 2, mask and 4, that is, one has already come, so I'll do it. So this is fine. So if we haven't used the previous one, okay, and if we haven't used the previous one, we have both the choices, either to pick up this index or not pick up. So if p equals to 1, so if p equals to 1, that means we have a 1 at this point. That means we are at a 0. So if 1 has already come, then we have okay. All are getting yes. Okay, let's try this one. Okay, let's see. Is not equal to -1, then I return that. Otherwise p equals to this. If mask and 8, that means we have used the previous one. So if p equals to 1, then we can do index plus 1 mask or 4 and not 8. That is or 8. Yeah, that will be flipped. Fine. Otherwise, if we have a 0 here and if mask and 4, that means else dp at index mask equals to helper at index plus 1 mask or 2. Because we are skipping this one and we're not taking 2 here. Oh, okay, we are taking 2 here. So if we haven't used the previous one and we are at 1, then we can either pick it or we can leave it. Yeah. If mask and 4, that is 1 has already come, then you will have to skip this one. I don't see what is the problem here. This is giving me a no, but that is giving me a yes. I don't know how. dp at ij equals to I have 3 bits here. It should be 1, 2 and 4, yeah. Okay, I can take it as 16 only. Because I've made a mistake here, there were 3 bits. So I should make it 16. Okay, this seems to be working. Let's submit it. Fine. That took a lot of time. That took like 20 minutes. And I think there is a greedy solution to this problem for sure. But yeah, let's see. So I've done this using DP with Bitmask, but I'm pretty sure there is a greedy solution to this problem. And this took a lot of time, obviously. So let's say you're standing on the xy plane at point 0, 0 and you want to reach point nn. You can move only in 2 directions, to the right horizontally and in the direction that increases your x, or up vertically that increases your y. Okay. Your path will have the following structure. Initially you choose to go to the right or up, then you go some positive integer distance in the chosen direction. Okay, distances can be chosen independently. After that you change your direction and repeat the process. You don't like to change your direction too much, so you'll want to, so you will make no more than n-1 direction changes. As a result, your path will be polygonal chain from 0, 0 to nn, consisting of n, at most n segments. Oh, okay, that is fine. Where each segment has a positive integer n and vertical length this. Not all paths are equal. Fine. Using these, you have n integers, where Ci is the cost of the ith segment. Using these costs, we can define the cost of the path as the sum of the length of the segments multiplied by the costs. Fine. Then the cost of the path is equal to this. Find the path of the minimum cost. Find the path of the minimum cost and print its cost. So, what is the range of n? N can be up to 10 to the power 5. Okay, fine. And what is the sum of all the lengths? Like here, to reach 2 2 you need to make at least one turn. So your path will have exactly two segments, one horizontal and one okay, 2 into C1 and 2 into C2. Fine. At most n steps. So if I'm here, I can go here, and then I can go here, then here. And then here. Right. 1, 2, 3, 4, 5. So if I move only once, and then here, then here, then how many steps will this take? So there are n horizontal steps here, and then there are n vertical steps, right? So, and you need to do it in n steps. Okay, can I solve this independently for horizontal and vertical? I think I can do that. So if I have the horizontal paths, horizontal ones as these, so they will be basically the odd ones. Yeah, these are the odd ones. Let's say this is A, this is B. So if I travel, let's say x distance here and then y distance here, so the sum overall should be n. The sum of xi's, let's say this was x1 and this was x2. So we want the sum of xi to be equal to n, and the summation of ci into xi, we want this to be as small as possible, right? So how do we do this? Okay, so these are the values here. And if I have this array, I can choose a prefix of this and then assign calculate the answer for this. So in overall I have to travel n. So let's say I'm picking up this prefix. So what can I say? What I can do is for the smallest number in this prefix, I can assign it like if the length of this prefix is, let's say, k. So I have k minus 1 segments here. So what I will do is I will assign 1 1 to each of these numbers, and then the remaining I will assign it to the minimum number. Yeah, right. This should be fine. Yeah. Into n minus two zero two 39 20. Okay, let's see. So I will have 4 2 and 4 4 2 and 4 in one of them. Yeah, 4 2 and 4. Answer is 7 here. So I need to move 5 and min here. And okay, this should be n minus x like this. I hope this works now. Yeah, seems to be working. Wrong answer on test 2. Okay, let's see what are we doing wrong here. So I'm calculating the minimum value, and then I'm moving 1 for all of them. Okay, I think there is something wrong here. Sum here minus p. P should have been the one that was getting added here. I think this was wrong. Yeah, this is fine. There was some typo, I guess. Otherwise it was fine. Okay, what is the issue now? Min here into n minus x. Should this be? Yeah, this is already long. So I'm calculating the minimum value till here. And that will be, oh okay, one thing that I missed here was, yeah, so if I'm using x horizontal paths, so then the answer for that is fine. If I'm using x horizontal paths, then I definitely need to use either x minus 1 vertical paths or x plus 1 vertical paths. Okay, this is something that I missed here. Okay. So if left is okay, that should have been passed by reference. Shouldn't this have been here? Answer left is fine, answer right is fine. Okay, seems to be fine now, but let's see. Maybe if they could have provided a test case in the sample only, which was considering that case. Okay, wrong answer again. Now what is the issue here? So I've calculated the answer up and the answer down. Okay, I don't know what is the issue with this code now, because it seems to be fine. I hope I'm calculating this answer properly. Sum here minus min here. N minus x. Hmm. 3 1 and 4 2 4. Oh, okay. So if I'm using the first one as n times, yeah, if I'm using the first one as 1 2 times, then I can use it only till here. It should not be right. Okay, finally. Now this one took a very long time, and I've also had 3 wrong summations on this, so I'm not expecting my rank to improve by a large amount. But yeah, we'll have to do D in order to save this round for sure. Okay, let's look at D. So I haven't spoken much in this screencast because yeah, the problems are not getting done. So given 3 positive integers in C, D and X, you have to find the number of pairs of positive integers A, B such that equality C times LCM of, okay, so they want C times LCM of A comma B minus D times GCD of AB equals to X. Okay. So we want C times LCM of A comma B minus D times LCM of, oh, that is GCD of a comma b equals to x. So first of all, the GCD of a and b divides LCM of a and b. Yeah, so LCM of a comma b equals to a into b divided by GCD of ab. Yeah, so in other words, we want c times a times b minus d times GCD of ab squared equals to x times GCD of ab. Yeah, so if we can convert it into a form of a quadratic equation, we'll have something like this. So a into b is okay, let's try to look at this in the form of a quadratic equation. So we have k square times d plus what is that, x times k minus c times a times b equals to 0. We want this. So if I choose my a and b, let's say the GCD was 1. Okay, yeah, so 1 times d plus, yeah, d plus x equals to c times a into b. Yeah, and we want the GCD of this to be 1, and let's say the GCD was 2, so we'll have 4 times d plus 2 times x equals to c times a into b, where the GCD of a and b is 2. So we can extract 2 from this, and then we can have the GCD of a and b equals to 1. Yeah, okay. So the entire thing is that I have this d times p square plus x times p equals to c times p into the product of two relatively prime numbers. Yeah, a into b such that, and I can cancel out this p here. Yeah, so the equation actually becomes like this: p times d plus x equals to c times a times b, and a and b are relatively prime here. Yeah, so if I have my d fixed and I have my x here, yeah, so if I put in 1 here, then this becomes d plus x divided by c. Yeah, d plus x should be divisible by c in that case. Okay, let me think about it on a pen and paper. So I have so all I need to do is I need to see this C into A into B, or let's consider it like this: C times M minus D. This should be equal to X divided by P. So I can iterate on the divisors of X, and if P divides X, then I can consider this point, let's say F, then I can do F plus D, and if this is an integer, then this is the point. Yeah, this works. Finally, this should work. Yeah. Okay, still this is not just one point. I can make many points out of this. Yeah, this will give a wrong answer actually, but I need to find what should I add to my answer. What should I add to my sum here, basically. So I can print this. So what are the number of ways to choose A and B such that A and B are relatively prime here? There is just one way to do that here. So what was this equation? A times B equals to X divided by P plus D then divided by C. Okay. Two numbers whose product is 4 and they are relatively prime. Okay. If x modulo I equals to 0, int f equals to x by I. Yeah, that is fine. Then f plus equals to d. Let's consider the first case only. Four. Okay, I think I'm missing out something. I think I have to think about it. Okay, what are the points that they're finding here? 1, 4 and 4, 1. Fine. Oh, right. So, it should have been like that. A and B can be swapped, right? Yeah. If f1 modulo d is not equal, so I can just double it. x modulo I equals to 0. How come it is coming as 2? Oh yeah, that is 1. Yeah, that is fine. So we have 2 there. 2 can be constructed in one way. So if I can find the number of primes that divide a particular number. think this should work, but yeah, I'm not sure about the time limit. Also, there might be some issue with the memory as well. Wrong answer on test 2. Yeah, the memory seems to be fine here. Let's see. Sum plus equals to expo. That number can be up till 10 to the power 7. So f1 can be only up till 10 to the 2 into 10 to the power 7 x by I. Oh, this should have been LL here. Still, let me just check all this. It should have been LL first of all. Okay, wrong answer on test 2. I think I'm making a lot of vague submissions here. I should check my code properly first of all. So this is the limit. And the limit seems to be fine. Then I do v1 and j++. So for every prime that divides that number, it can either be in the left half or in the right half. F by C. Fine. Number of ways to make 2. C was 3. I don't know, seems to be fine. Plus equals to D. Okay. And if f modulus D equals to 0, debug f by C. Number of primes that divide it. The number of primes that divide this. should work, but I don't know what is the issue here. Maybe there is some overflow or something, but the logic seems to be fine. Let me read the problem again. Maybe that might help. Times LCM of AB equals to A into B divided by GCD of A into B. Yeah. So if I do that, then we have C into A into B minus D times GCD of AB whole squared equals to X times GCD of AB. Then I can represent A into B as GCD squared times K1 into K2 such that K1 and K2 are relatively prime. Then X for GCD plus D. How is it coming as 2 here? This should have been I, right? Oh my god, that was a blunder. I don't know what did I do here, but that was a straight blunder here. It is taking 4 seconds to run here. What if I make that as int? That was a very big blunder there. First of all, I hope the time reduces. This should be fine now. But it was fine on the very first attempt, I guess. It should have been v1 at I. Oh my god. That just wasted such a lot of time. What a huge typo that was. So what I was doing was, this should have been v1 at I and I was doing v1 at limit this whole time, and the logic was right. Okay, so I don't think I'll be able to solve the fifth problem with the amount of time that is remaining now. So yeah, that was it for this screencast. And how was it working on the sample? I still have no idea. It should have failed on the sample itself. Okay, so it is showing because of the previous rank. I don't know how did I commit such a big typo here. Okay, let me still read problem E. Given two strings x and y both consist only of lowercase Latin letters, let mod s be the length of string s. Let's call a sequence AB a merging sequence if it consists of exactly x zeros and ones in some order.